G'day, Lance from Motive Power, back again with the next episode in our series on professional off-highway vehicle design. Today we're talking about slippery slopes, the issues concerned with grades. So just a short video today, but still on an important topic. We're going to talk about the grades and the things you should consider about grades when you're designing your vehicles and a few of the traps. But first, there's terminology, and for that we're going back to the whiteboard. So back at the whiteboard, we're going to talk about how grades are designated. You might say they're 1 in 4 or 25%. 1 divided by 4. Or you might say 14.8 degrees, I think it is. All of those are the same grade, and it all comes from a triangle that you might draw like that. Off the horizontal, 1 unit of rise for 4 units of run. Please note the run is on the horizontal, it is not on the hypotenuse. If there are situations where you need to define it on the hypotenuse because you can't measure it any other way, you need to clearly state that. At small angles, it doesn't make much difference, but it does once the angle increases. So as I said, 1 divided by 4 is 25%, and the angle is in here. And it's that angle that you will use quite a bit if you're going to work out tractive effort and traction. So now you know the grade, you can begin to use it to design the vehicle. And we're going to draw a fairly basic vehicle here. Never said I was an artist. And we'll put a center of gravity somewhere in there. That vehicle presumably needs to go up that hill. The rating of the steepest hill it can go up is its gradability. And that's something you should specify as part of your design. However, ideally you can start the vehicle on the hill. Starting has a greater resistance, so you need to work out what your vehicle can do on the specified grade, and that is its startability. It may be that you need to specify the vehicle condition, perhaps laden or unladen, or some other configuration. Now, a big part of why grades are important comes back to this center of gravity. I'll draw a line of force representing the weight. You can immediately see that the weight has shifted more towards the rear wheels here and away from the front. But if I break that force into its components, perpendicular and parallel to the grade, what's happening is the grade is forcing the weight to create more resistance. And it's reducing the component of the weight that is perpendicular to the surface. So it's actually reducing your traction capability. So as the grade increases, your resistance goes up, but your traction capability goes down. So here we are back on the farm on a beautiful autumn day. It's about 31 degrees and a little breeze that I hope doesn't upset the microphone. I wanted to use some real world examples of grades, because talking about grades on paper is one thing, experiencing them in reality is another. We're going to use the Ventrac 4500P as an exemplar again today, and I have it parked here on a 15-degree slope. Now that's 1 in 4, 1 up for 4 horizontal. So 1 in 4, 15 degrees from the horizontal, roughly. Now why 1 in 4? Because it happens to be the sort of grade that's used for the production of drifts in underground mines. A drift is an inclined tunnel leading into the mine, and it's inclined so that vehicles can drive up and down. The complication is the shallower the grade, the longer the drift, and the higher cost to produce it. So mines try to optimize that length but still be able to use vehicles. And 1 in 4 is the general accepted grade. It may not look too bad, but try walking up a 1 in 4 for more than 10 steps and you'll know how steep it is. Check my makeshift plumb bob here, might give you an idea of how steep it really is. We're already experiencing trouble on this grade. This tractor is rated to 30 degrees, so 15 is a doddle. But you'll notice I've got the bucket down and the teeth in the ground, such as it is. We're working on the compost pile because it's the safest place I could get a grade. The teeth are engaged because the brakes aren't holding. Ventrac has a park brake on the front axle only. On this grade, on this very loose ground, the brakes are working fine. They're locking up the front wheels and the wheels are just sliding down the hill. The bucket's there to prevent that. This is a prime example why grades are important even outside of performance calculations. It affects even your park brake. In a perfect world, there'd be brakes on all 4 wheels. But in this grade, we might still have a traction problem. So now I'm going to try and set it up to 30 degrees. And we'll just see if we can see how much difference that is. So ultimately, I chickened out. This is only 25 degrees. Took a little bit of work. Had to put the bucket in harder to get it to stay there. But 25 degrees is about 1 in 2.1. So that's effectively, for every 2 steps forward, you go up 1. It's quite a steep grade, and definitely not one you would want to operate on for any long period. You definitely don't want to walk on it, again, particularly on loose material. So grades are important. On paper, they might look all right, but sometimes in reality, it's a very different picture. Look at the plumb bob again, way back. And what that's indicating is there's a lot more load back here. Granted, the bucket is empty. Normally that axle would be the most heavily loaded one, but right now it's here. My traction and braking is back here, but my park brake is there. things to consider in your design.
Considering grades is a very important part of your vehicle design. Even if you've got low grades, the resistances can add up. Now, I've talked about trust but verify. I don't trust what any client tells me about grades if I can verify it myself. So again, trust but verify. What the client thinks is the grade may not be the real grade. One easy way of confirming that and verifying it is a tool on the phone. Now this is Smart Tools app, and if I bring it in even closer, you'll see it's a protractor. And we'll get the glare off it. As it rotates, I can read the angle. So I can basically just put the phone on the ground and it will give me a number that I can then compare to what the client has actually told me. Make sure you verify as much as you can. If you think small grades can be ignored, that's a risky slope. Let's look at one particular example.
So we're back to a Bliss Fox F1 450 with his great big Airbus on behind. Airports have a maximum grade of 2%, but when you're towing something like 545 tonne, every little grade matters. This is actually a pushback up a 2% grade, and you'll see the tractor, as big as it is when you stand next to it, is dwarfed by the aircraft it's moving. Now this photo starts to show the grade. You can see the ground rolling away and starting to hide the tyres. Grade is very definitely there. 2% of 545 tonne is a considerable number. And this is the image that really sums it all up. You can see that the combination is well below the level of the taxiway. And that tractor has to haul that 545 tonne up that grade onto that taxiway. Small grades matter. You have to have the tractive effort to do the job that is required.
So you must make sure that you've got the tractive effort to work on the grade. But it's also important to make sure you have the traction on the grade to do it. You may have sufficient grunt, tractive effort, but you can't apply it because the grade's too steep, the surface is too bad. Think back to Venny on the compost heap, very friable ground, and that limited the traction. So make sure you've got the tractive effort, but make sure you've got the traction to do it too. Again, this is one of the areas where the question of diff locks can come in. They will give you an advantage in traction, but whether it's sufficient is another matter. So only a short video. Slopes are important. They can be crucial. You must consider them. So run the numbers. Make sure that the vehicle has traction, tractive effort and traction. If you're not sure about traction, the Caterpillar handbook has some real world figures in the back and they can come in very handy. Do the numbers, do your vector diagrams, work out that everything's going to be fine, and then move confidently on to the next design.